Okay, so picking up right where we left off, when we hit the space bar, we instantiate the missile, which is good. Now we need to give that missile motion. We need to give it velocity. So there is a process known as LERP. Basically what it says is, here's a start point, here's an end point, travel a certain distance from one to the other. So it interpolates. It finds a position in between two given positions. So you have to give three arguments. What's the start position, what's the end position, and what's the percentage of the distance you want traveled. So it's not quite the same thing as giving it velocity, because if you give an object velocity, technically that's fire and forget. You apply the velocity, and unless you have gravity working, that object is going to keep moving. This, you're actually just changing the position of the object, so it's kind of a fake velocity. You can try doing this. You can kind of rig something where you set a velocity. You certainly can try that too. So I'll show you the LERP, and maybe we'll take a moment to also show the kind of faking it with the velocity. So what we're going to do is, the first thing we're going to do is we need to make, in the GM script, we're going to make obj position static, and we're going to create a new variable, public static vector2 target position. What we're going to do is every single frame this gets updated with the new mouse position. Well, what we're going to do is once we fire that missile, if this keeps changing, then that means if we say, okay, fire the missile at this point, if this point keeps changing, because it does every single frame, then the mouse is going to chase the cursor, and we don't want to do that. Once it's fired, we want it to go to a certain spot in space. So what we're going to do is when you hit the space bar, we need this extra variable to grab it. Actually, just to be consistent, let's make the P capital. So in your GM script, you should have public static vector2 object position, or obj position, public static vector2 target position. Go ahead and save that. Next, we're going to create a second script, create C#, and we'll call this missile control. So we click on the missile, we add the missile control, and we go ahead and open that up. So what we need is we need to set target position to the value of object position, and we only want it to happen once, so therefore it should happen in the start section. So as soon as the rocket is instantiated, that's when start occurs. And so we're going to take the obj position of the mouse and drop it into target position. So GM dot target position is equal to GM dot obj position. Save that. Now we're going to use LERP, and here's what it looks like. And I'll explain this. I'm just going to paste it in so I don't make any typos. Okay, so in the update section, so this will happen with every frame, and this is the missile control script, so this is attached to the missile. Transform.position, so ultimately we're changing the position of the object the script is attached to. It is going to be a vector2. And there is LERP, as we mentioned, parenthesis, so the start position. So let's take the current position, so transform.position, and we want to use GM dot target position. So the start position is the current position of the rocket. The target position is just that. It's the position that the mouse was at when the space key was hit. and then the distance is going to be 0.01. And we have to use the letter F again because it's vectors and we're using a fraction. So now watch what happens. If everything works correctly, it will shoot, but it slows way down when it approaches the target. The reason for this is because this is a percentage of the difference. So as the current position gets smaller and smaller and smaller, then the percent, even though it's the percentage as a percent is fixed, the absolute amount of this small distance is therefore a smaller amount. So since the distance is smaller, 0.01% would be a smaller amount every time. So you'll see what happens. It's going to move and then slow down. So it starts off and then slows down. And again, it's because it's doing a fraction of the difference. So what we need to do is we need that fraction to increase as this decreases. So a couple ways to do that. You can have this based on time. If you've watched any of my other videos, you can use time.delta time to have another variable change based on passage of time. You can kind of fake it and have it be based on frame, but the problem is if you're on a slower system, this number increases slower. If you're on a faster system, this number increases faster because, again, this happens once per frame. So if this is running 100 frames per second and you have this number increase with every frame, then it increases 100 times per second. If it's running at, say, 60 times per second, then this will increase 60 times per second, so it would increase slower. So what we'll do is we'll create a new variable. So public float timekeeper equals 0. Timekeeper plus equals, in other words, take the current value of timekeeper and increase it by a certain amount. Increase it by time.delta time. So, if you recall math class, what's delta? Delta is the change in. So this is saying what's the change in time. And it gets run once per frame. So how much time has passed since the last frame? So, if timekeeper, we don't want to do equals because we don't know how much time has passed, but we want it to, so we'll use greater than, say if it's greater than 0.05, and this is kind of just a guess, trial and error to get a number that looks right. So if 5/10 or 5/100, excuse me, if 5/100 of a second has passed, then we want this number to increase. So that means we need one more variable for that. So public float and actually let's call it dist, keep it short for distance. And that starts off 0.01 f. And so yes, even when you're declaring the variable, you have to put the f there if it's a fraction. So now we replace this with frac dist. And now we can put frac dist in here. So frac dist. And this too gets incremented, and we'll say by 0.05. And something that I often forget to do is this variable needs to be reset, because once it hits the threshold, if you want this threshold to be hit repeatedly, then you need to reset it back to 0. Otherwise, you've basically created a single delay, and then each increment after that is done once per frame, so it kind of defeats the purpose of this whole timekeeping. So if you want this this delay to occur again and again and again, make sure you reset that to 0. And let's see how that looks. So let's go ahead and save that. Let's go ahead and run it. And we'll shoot. So kind of fast. Probably a little bit still too quick, but we'll go just one more time. But maybe we'll tweak that it doesn't have to wait quite as long to offset it. So that's purely game balance as far as how quickly you want it to move. I won't play around with that anymore because you can really go down the rabbit hole. That is really, like I said, that's game balance. That's the kind of thing that you do in your beta testing, whether it be private or public beta testing, however you do it, that's the kind of balance you do. So, now that we have the missile firing, we want to indicate where that missile is going to hit, because as we said, you move the mouse and it's still going where you were. So what we want is we want an indicator to appear there. I'm going to be lazy, and rather than using a new one, I'm just going to take the crosshair. So rather than using a new image, we're just going to use a pre-existing image, drag and drop it into the scene. I'm going to click on color, choose red. And now what we're going to do is we're going to take that crosshair and we're going to bring it back into our asset area, and now we've created a prefab. So we'll delete the original, and now we need the GM object to be aware of this. Why? Because the GM object is what's looking for the key press. So might as well have the GM object also instantiate the crosshair, because we already have code looking for the key press. So that's right here, instantiate the missile object, and then the missile fires. So we also want to instantiate the lock-on target. So in the GM area, public, transform, lock on target. Save that. Click on the GM object. Here's the new variable. Put the crosshairs on it. And so now it's going to display the image. Now, because of the offset of the mouse, you're actually going to see the crosshair appear slightly to the upper left. So, oops, sorry, I didn't actually put in the instantiate. So instantiate lock on target, and we want it to instantiate at OBJ position. We want to use the lock on target rotation. Now, most of the time, if you've seen any of my other videos, usually when I'm using instantiate, I do a variable dot position. The reason why we don't have to is because this is a position. Not just because it says it, but because if you come up here, you recall, it's a vector 2 to begin with. So I'm not trying to extract the position from an object, I'm just putting the actual position in there to begin with. So let's go ahead and save that. And now it'll work. So sorry about that minor misstep there. Kind of got ahead of myself. There we go. And like I said, you can see it's appearing a little bit to the upper left. Not a big deal for a game like this. There's a couple things you can do. You could offset the red circle so it appears towards more to the lower right. So you offset it over to the right and down so it's properly overlaps the cursor if you want. Not a big deal for a game like this. And now that we've done that, what we want is we want the missile to explode when it hits that. So we'll click on the prefab, we'll click on add component, we'll click on physics 2D, and we'll click on box collider. We won't be unforgiving. And we will click on trigger. So now this will check for overlaps. And what we'll do is, since we already have a script for the missile, we will go to the missile control, and outside of update, outside of start, we'll do void on trigger enter 2D collider 2D other. So it's colliding with the other object. And what we'll do here is, if it collides with another object, if other dot game object dot name equals, the name will be the prefab with the word clone appended to it in parentheses. So crosshair clone and destroy game object. So in the missile control script, we now have a trigger, and it's looking to see if a collision is occurring with another object. If the name of that other object is the crosshair, then go ahead and destroy what this is attached to. This is attached to the missile. So we need to do a separate destruction for the crosshair. But we'll just test. And I missed an equal sign, as always. The missile does not have a collider box. So physics 2D. We'll make this a polygon collider though. And it's a trigger. There we go. So like I said, now we just need the target to also be destroyed. So we'll put a self-destruct script on that, and we're also going to have to create an explosion, and then we'll start working on the enemies attacking and how you go about scripting that. Okay, so I think that's it for this video.